The U.S. Department of Energy is expected to announce Tuesday that its researchers have achieved a major scientific breakthrough regarding nuclear fusion, a technology seen as a possible revolutionary alternative power source. Scientists have been working for decades to develop nuclear fusion, touted by its supporters as a clean, abundant, and safe source of energy that could eventually allow humanity to break its dependence on the fossil fuels driving a global climate crisis. The Energy Department has refused to give any specific details about what it will announce Tuesday, but a Financial Times report over the weekend has set the scientific community abuzz. According to the UK-based outlet, researchers at the Lawrence Livermore National Laboratory, LLNL, in California have succeeded for the first time in producing a net energy gain from nuclear fusion, meaning more energy was produced in the reaction than was used to activate it. If the achievement is confirmed, that is a true breakthrough moment, which is tremendously exciting, said physicist Jeremy Chittenden with Imperial College London. It proves that the long-sought-after goal, the holy grail of fusion, can indeed be achieved. Nuclear power plants around the world currently use fission, the splitting of a heavy atom's nucleus, to produce energy. Fusion, on the other hand, combines two light hydrogen atoms to form one heavier helium atom, releasing a large amount of energy in the process. That's the process that occurs inside stars, including our Sun. On Earth, fusion reactions can be provoked by heating hydrogen to extreme temperatures inside specialized devices. Researchers at the LLNL use the massive National Ignition Facility 192 ultra-powerful lasers, all pointed into a thimble-sized cylinder filled with hydrogen. According to the Financial Times, LLNL scientists recently produced about 2.5 megajoules of energy in a nuclear fusion reaction, or about 120% of the 2.1 megajoules used by the lasers to initiate it. Decades to achieve. That result would finally provide proof for the physical principles outlined decades ago by fusion researchers. It would be a success of the science, said Tony Rollstone, a lecturer at Cambridge University. Like fission, fusion is carbon-free during operation, but has many more advantages. It poses no risk of nuclear disaster and produces much less radioactive waste. However, there is still a long way to go before fusion is viable on an industrial scale. To turn fusion into a power source, we'll need to boost the energy gain still further, cautions Chittenden. We'll also need to find a way to reproduce the same effect much more frequently and much more cheaply before we can realistically turn this into a power plant, he added. That could take yet another 20 or 30 years, Eric Lefebvre, project manager at the French Atomic Energy Commission, told AFP. Climate experts, however, warn that the world cannot wait that long to reduce its greenhouse gas emissions and limit the worst effects of global warming. Other nuclear fusion projects are also in development around the world, including the major international project known as ITER, which is currently under construction in France. Instead of lasers, ITER will use a technique known as magnetic confinement, containing a swirling mass of fusing hydrogen plasma within a massive donut-shaped chamber.